first confirmation that when a binary neutron star merger happens, then that is two neutron stars that were spiraling towards each other merges, it produces a short gamma ray burst. This was the first actual evidence of that. This marked the first observation of a messenger other than photons from a gamma ray burst, because generally all we had measured from a gamma ray burst is the gamma rays, right? In order to understand the physics of gamma ray bursts and to probe it with other things, we would need other messengers, and in this case we got gravitational waves from them. Indeed, no other messengers or particles have been known to come from gamma ray bursts, although theories predict that gamma ray bursts are environments where particles could get accelerated to the highest energies. So you can see now how gamma ray bursts would be sort of a motivation of particle astrophysics, or the neutrinos that I was looking for, because they are natural accelerators of particles. The detection of gamma ray burst neutrinos would provide unambiguous proof for hadronic acceleration in these cosmic explosions, and could also explain the origin of the cosmic ray flux at ultra high energies. So because gamma ray bursts are so far away, they're very extreme environments, right? They're very extreme natural accelerating environments. And we have sort of theories for what might be happening, but the only way to confirm these theories is to actually measure certain things from these gamma ray bursts. So for example, that thing I was mentioning, the excitement about getting the neutron star merger evidence, getting the gravitational waves as well as the gamma rays from that same event, tells us that, okay, yeah, this is confirmation that neutron star binary will give you short gamma ray bursts, and that's good. But then there's other questions also about gamma ray bursts, about that particular type of environment. For example, there could be hadronic acceleration happening. So this is the hadrons within that. It's a particle physics-y type of thing, but basically whether or not gamma ray burst environments will accelerate particles in a certain way or not, it's not confirmed. And it's not like gamma ray bursts are happening like right in our neighborhood. So we would need these types of evidences, and the more measurements we can make in multi-messenger type of way, whether that is gravitational waves or cosmic rays or neutrinos or actual gamma rays, the better. That's the more we have of different types of evidences from the same phenomenon, the more we would be able to tell exactly what these types of environments are doing. Okay, so the detection of gamma ray burst neutrinos would provide unambiguous proof for hadronic acceleration in these cosmic explosions. So they're also called cosmic explosions, various names of gamma ray bursts, and could also explain the origin of the cosmic ray flux at ultra high energies from gamma ray bursts, from gamma ray observations alone. So just observing the gamma rays, which is light. Theorists have hypothesized that regardless of the nature of the underlying source or progenitor, so progenitor meaning like that, either the star that's dying or the neutron star merger or whatever, gamma ray bursts are produced by the dissipation of the kinetic energy of a relativistically expanding fireball. Protons may be Fermi accelerated in this dissipation region to energies greater than 10 to the 20 eV. Interactions between fireball gamma ray photons of energy around 1 MeV and accelerated protons of energy around 10 to the 15 eV could lead to photomeson production of pions, which upon decaying would result in an accompanying burst of 10 to the 14 eV neutrinos. So this is actually a whole theory that some of these gamma ray burst theorists have come up with. And so if we saw neutrinos in association with gamma ray bursts, that would be like a huge confirmation of all this theory behind how gamma ray burst fireballs work. So that's why basically the gamma ray burst, especially at those high energies, because remember I was working on a particle astrophysics experiment looking for very high energy neutrinos, and getting neutrinos that are that high energy, you need the specific type of event which would actually make that type of neutrino, right? So that's why I was after these things. I was looking at them and trying to understand gamma ray bursts better, because they would be the type of environment that might potentially make those very high energy neutrinos. So now we will talk about the gamma ray burst emission. Steven says, love your kitties. Thank you.